Presentation of dialogue on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family's legacy of building the great state of Idaho.
With the Obama administration offering more than $8 billion to jumpstart the nuclear power industry, what's going to happen to the Idaho National Laboratory? We'll ask its director. Stay tuned. Dialogue is next. Hello, I'm Joan Cartan-Hansen. Thank you for joining us here on Idaho Public Television, on the World Wide Web, and on public radio stations. The Idaho National Laboratory is the state's third largest employer, with more than 4,100 employees. And with the Obama administration's latest push for nuclear power, the INL futures looks bright. But this research laboratory is about more than just nuclear energy. Biofuels, next-generation batteries, even homeland security are all part of the INL's mix. The INL's director, John Grossenbacher, joins me now to talk about the future of the INL and what it means for Idaho. Thank you for being here, sir.
It's a pleasure being here, Joan.
And of course, we want to hear from you. Give us a call, toll-free at 1-800-973-9800. Let's start off the top. That's a lot of money going into the private industry. But will there be benefits for the Idaho National Laboratory?
Absolutely. I mean, that money goes for loan guarantees that will reduce the financial risk of building new power plants in the United States, and they're starting primarily in the southeast where there are existing plants and approved sites. But what it'll mean is the fielding of new technology and research and development to continue to improve those kind of technologies. So it'll mean more work for us, and it's good for, I think, America's energy future.
Why?
Because I think nuclear energy is an extremely important energy source. Today, it's about 20% of our electricity in the U.S. I think we're going to be using nuclear energy for hundreds and hundreds of years. We need renewables. We need certainly an emphasis on efficiency, and we need fossil fuels for the right kinds of things, like transportation fuels. It's hard to beat liquid transportation fuels for heavy transport. Batteries are probably okay for light transport, but nuclear energy to generate electricity and to make process heat for industrial processes in particular, so that we're not using natural gas and those kind of very valuable limited fossil fuels for that application.
Are the reactors, this next generation of reactors, how are they different from those that happened at WIP and the other plants, the older style plants? How is it different?
Well, in general, I think they're more sophisticated in their design, which allows them to be simpler.
That's kind of
yeah. Well, it is. I mean, when the designs are less sophisticated, I think it's easier to add engineering solutions and safeguards and things that you think you might need because you're not so sure. But I think we're very sure. There's lots of performance history and lots of maintenance history, so we know how these machines work, and we know when pieces and parts of them break. How to fix them, and that's allowed us to redesign them, simplify them, make them even more reliable, even safer. So that's what the new plants will look like, and they'll be higher performance, more reliable, greater margins to safety. So I think, and when we build one today, I mean, you should reasonably expect to have it for about 100 years. And the ones we have today, we built and licensed for 40 years. We're extending most of them to 60. It's likely we'll extend some number to 80 and maybe even a century. The new ones we build them with the expectation we're going to have them around for a century. So that's a very important part of the energy infrastructure.
In terms of the mixture, where does nuclear power fit in the idea of green energy? Some environmentalists are bucking the trend and saying we need to go with this because of global
warming. John, I have to react to the term green energy because I think it always bothers me when we try to characterize energy sources that way, because I think in the end, all energy sources have costs, risks, and environmental impacts associated with them. There's no free lunch. If you want a lot of energy, you're going to have costs, risks, and environmental impacts. So I think nuclear, if it's allowed to compete, I think, in my opinion, I think nuclear energy has been demonized for for too long a time. But if it's allowed to compete on that basis, costs, risks, environmental impacts, it'll compete very well. Primarily, in the recent interest and emphasis, of course, is because you can generate electricity without greenhouse gas emissions. And in the U.S., I mean, 50% of our electricity comes from coal. It's currently fashionable to demonize coal, but there are the substantial greenhouse gas emissions associated with it. So nuclear offers an alternative to that, and that's why I think it's attracted the attention of environmentalists. Plus, I think people are taking a more practical approach to what our energy choices are. Again, there's no free lunch, and it's not just an American problem. We look at ourselves and say, well, if we just got more efficient and maximized our use of renewables, in my opinion, that's not enough to provide baseload power for cities and manufacturing
Is that the
plants.
baseload? And perhaps you should define baseload. Yeah. Is that why we can't just have solar and wind? Right. There has to be something else in the mix?
Yeah, it's all, cost, risk, environmental impacts. Renewables like solar, the challenges they have are they're intermittent, and by and large, like wind, they have to be distributed. So you have small energy sources and a lot of them, and then you have to collect all that with, if it's electricity, with distribution systems. So from the standpoint of, nuclear energy, of course, it's large, it's concentrated, and it's not intermittent. You want to use it, when we say baseload power, what we mean is you leave it running all the time. Because you know how electricity works. People wake up in the day and they turn everything on, electricity peaks, and then they go to bed at night, and it goes down to some other level. And if you generate electricity, meeting those peak demands costs you a lot of money with gas turbines or however you meet it. So what you'd like is a steady, very reliable source of power to provide whatever you need 24 hours a day. And in general, that's the way nuclear energy is used today.
We had a number of email questions, and one came from Travis, who wanted to know what's going to happen now that the Obama administration has withdrawn support for storage at Yucca Mountain.
Well, there's a couple issues associated with that. I think from the standpoint of nuclear energy broadly, there's disappointment in that there was a path for disposition of used fuel, and it was a repository, and now we said, okay, we're not going to do that. So there's some disappointment, I think, because now what are we going to do? And we've created a Blue Ribbon Commission to answer that question. On the other hand, it gives us the opportunity to step back for a second away from what I would call a lot of the adrenaline associated with the Yucca Mountain issue and reevaluate what our choices are. And we have choices other than what we call a once-through fuel cycle, take it out of the reactor and bury it underground. So that's one issue. I mean, we get the chance to again think long term, hundreds of years. It's not just this fuel cycle that we have, but we're going to have other nuclear fuel cycles, and think in those terms about our choices. The other thing of concern is that there are 70,000 metric tons of used fuel in the United States. Most of it is at the commercial reactor sites where the used fuel was created. In Idaho, we have about 300 metric tons of used fuel, and that was supposed to go to Yucca Mountain.
Yeah.
Well, now what? I will say that, in terms of protecting public health and safety and relative to its environmental risk, I mean, used nuclear fuel is highly radioactive stuff, but it's improperly designed containers and properly managed. It's concrete and stainless steel, and it's not difficult to protect public health and safety from used fuel if you just contain it properly. And certainly, the 300 metric tons in Idaho, I feel very confident, is of no threat to the environment or public health and safety because we manage it properly.
Let's get to our first caller. Steve in Idaho Falls. Steve.
Thank you for taking my phone call. Just a real quick question. We hear a lot about the INL's involvement with nuclear power, but what sort of alternative power sources is the site currently working on? And will we be doing anything more with space batteries for deep probes for NASA? And I'll listen to the answer. Thank you.
Thanks.
Well, thank you, Steve. The space battery work at the lab continues. We provide heat sources and electricity sources for deep space probes because the sunlight isn't intense enough, and also for some manned applications because you need the reliability. And the lab assembles and tests those devices and takes them to Cape Kennedy and turns them over to NASA. So that work is continuing. In terms of alternative energy sources, there's lots of work that goes on at the lab. We've got a long history, for example, in geothermal, in the Raft River plant in Idaho. There was a lot of work done on that design and at the Idaho National Laboratory. We do some work in wind. It's mostly wind surveys and how you would site wind devices. We're surrounded by enormous wheat and barley fields, and cellulosic ethanol, how you can take what today we treat as waste, which is wheat and barley straw, and convert it into a useful product. Ethanol is a very important aspect of our work. We work primarily in the feedstock area, and it sounds kind of mundane and easy, but it isn't. I mean, you've got to process enormous quantities of this stuff, and you can't do it in bales, you know. So how do you do that? And how do you control the moisture content and all those things to make it an economical and a successful industrial enterprise? And beyond that, the other thing that we're spending a lot of time and energy on, good use of the word, lately is what we call hybrid energy systems. And we think it's very important to think of how you can combine fossil, nuclear, renewable systems to produce an output. The output could be energy, it could be products, petrochemical products, whether that's diesel fuel or the feedstock for plastics. So, how can you take, we've always known, for example, how to take coal and turn it into liquid fuels. But the costs and the environmental footprint associated with that hasn't been satisfactory. Well, we think by combining energy systems, you can make those processes much more attractive, and we think that's going to have a lot of application for the future.
Is this the hybrid energy island concept?
Yeah,
what does that have to do?
Yeah. I mean, a good example is one of the attractive things about nuclear in that application is if you can find a carbon-free source of hydrogen and oxygen through the wonders of chemistry, you can take almost any carbon source, whether it's biologically based, coal, and what do you want? What would you like to make with the right catalysts and right conditions? And today, the way we get industrial hydrogen is we use a process that's called the steam reformation of natural gas. So it consumes natural gas. The other thing it does is it creates a lot of carbon dioxide. Well, with nuclear energy, you can disassociate water. You can take water and break it into, with heat and electricity, you can break it into hydrogen and oxygen. And now that allows you to feed these other chemical processes in a very clean and, we think, very attractive way.
Let me ask you a little bit about the work you're doing for Homeland Security, which is something that most people might not know goes on out at the Idaho National Laboratory. What can you tell us, I guess?
Well, we do a lot of work on critical infrastructure protection, and it's really as a result of the structure, the physical layout of the lab. I tell people if you fly over the lab at 40,000 feet, it looks like a small country, 900 square miles, and you have these industrial cities out there. Well, the infrastructure that supports those industrial cities, particularly the electrical distribution, is a great laboratory in itself. So one of the things of concern today is how people could attack with cyber weapons, attack electric grid controls. Most of the industrial control systems in the world, not just in the United States today, and that's sewer systems, water systems, electrical systems, factories, are computer controlled. And those industrial control systems were designed at a time when nobody could spell cybersecurity, let alone. So one of the things we do is, how could someone who means us ill, doesn't mean us well, how could they attack one of these pieces of critical infrastructure? So critical infrastructure protection is an important part of our work. We also do a lot of, because it's a very quiet electromagnetic environment, we do a lot of wireless communications testing. And there's some connections between wireless systems and industrial control systems, and some vulnerabilities associated with those. So that's where a lot of it is focused. We also, because we manufacture the armor for the Army and Army tanks, we have a lot of explosives and armor expertise. So work on different explosive devices and how to protect facilities and infrastructures from them. We do a lot in that area.
So really if I get my numbers right, about what's the split between the money that comes from the Office of Nuclear Energy versus other sources of contracts? It's about 60-40. Is that somewhere around right?
Yeah, that's about right. That's close enough. I mean, there's other offices in the Department of Energy.
Right.
We get some money from the Office of Science, for example, for our fusion work.
Right.
We do some work that's relative for the National Nuclear Security Administration, who's responsible for nuclear weapons. Our work isn't nuclear weapons related because the commercial nuclear fuel cycle involves materials and processes that are related to, or in some cases, can be used for a country to move towards a nuclear weapons capability. We work on what we call non-proliferation. How can we design those processes, materials, so that we can minimize the risk of people misusing materials somewhere around the world. So different offices from the Department of Energy, the Department of Homeland Security, Department of Defense, some private sector work as well.
And you have over $1 billion in
$1 billion
research.
this year.
We're
We're glad to see that. It's when we put together the laboratory, the new Idaho National Laboratory in 2005, it was a little over a $500 million business, and in this time of a lot of economic strain and hardship, it's great to see the business continue to grow. It's clear that we're doing the right work. I mean, in the end, that's what we try to do: perceive the long-term needs of the country and get capabilities, and that means people first. Also machines and buildings, but people first, who work on the really hard problems, the really difficult ones, because that's where we can add value. And it's obvious that we're making the right choices in terms of those capabilities.
Well, let's talk a little bit about the people who work at the Idaho National Laboratory. There are about 4,100.
Right.
My understanding is that in the next 10 years, about half of those people are going to be coming up on retirement age.
That's right.
How are you going to be able to start dealing with the turnover?
Yeah.
Especially considering the state of funding for higher education in Idaho.
No, it's a real challenge. I think the biggest challenge to the advancement of nuclear energy in the U.S. is the human capital challenge, not just at institutions like ours, at laboratories, but in the industry as well. Well, it's pretty simple. I mean, we take our skill sets, whatever it is, take a group of people that provide some set of skills and look at the demographics and say, okay, what are our choices here? Can we keep some of these people that want to retire? Can we keep them part-time and hire a bunch of people right out of college and have them train and mentor so that we can transition? Because experience is just so important, and it's in research, development, demonstration, and then deployment of technology. So it depends on the particular skill set, but we look at each group and say, okay, what are we going to do? In some cases, do we need to retain that capability? Can we hire it somewhere else? Can we buy it somewhere else, or do we have to have it here? Or do we need to own it, grow it, and then how do we do it? And each group is different in its demographics, but it's a serious challenge, and it of course spurs our interest in our activities in higher education and K through 12 and science, engineering, math education, because we need those people. The country's going to need those people.
Does it concern you, the state of funding for higher education in Idaho?
Well, I think the specifics of the funding of higher education, I think, in the technical areas around the country are concerned to me. I think, and I think it's fair to say, to a large extent, we have deindustrialized the country, and so there hasn't been a demand signal for a lot of these skill sets, a lot of the hardcore engineering, physical sciences skill sets. That needs to change. But I think it's a product. There's certainly the issue of how much in state schools, for example, the states and communities can afford to support it. But there's also the issue of what are the programs at those schools, and do they support the kind of things that we think are necessary. And I think the real issue there has been the demand signal hasn't been there. Now we're seeing that change. I think a number of years ago there were in the tens in terms of nuclear engineering majors in the state of Idaho and the 3 universities. Now I think it's up to about 250. So and that's not because that's because they see jobs.
That's right.
And I think that's been the issue.
Well, there was a growth as the industry began after World War II. There was this push for more people going into science.
Right.
Is that what we need? We need a national call to arms to get kids to get into science?
Oh, I think so. I think science, engineering,
or is it going to be
math,
economics? You're going to go into science because this is where you're going to find jobs and make money.
It's both. It's both. I think I think it's only sustainable. I mean, cheerleading and exhortation, no matter how good, will only lead you so far. So I think it's only sustainable if the jobs are there. But that means that we have to have industrial scale activities, that produce energy, that produce value-added products that this country and the rest of the world want to buy. So, we need to compete. It's not that we can do it in isolation from the rest of the world. And I don't think we Americans should be afraid of competition. But it's not easy. I mean, there are a lot of countries that are working very, very hard and put a lot of emphasis on education. So, I think it's important for us to see that, see what it means for our economic future, and face up to that. And time's up. Let's get on with it. Let's get it going.
Let's go back to the phones.
Okay.
Doug in Meridian. Doug.
Hi, thanks for taking my call. I just have one quick question. What plans, if any, does the U.S. have for reprocessing used nuclear fuel, basically to move away from the once-through policy?
Well, thank you, Doug. As we were talking about the Yucca Mountain decision earlier, previously the policy in the United States was a once-through fuel cycle, put it in a reactor, pull it out, and then dispose of it underground. One of the choices has always been to reprocess. France, the United Kingdom, Japan, Russia, all reprocess. They use variants on technology that were first developed in the United States. So we could do that. We could do some more research and development, say, is there a better way to reprocess so that you get more energy out of the uranium that you dug out of the ground, and so that when you're finished, the material that you have no use for and have to dispose of that's radioactive is much less onerous in terms of how long it lasts and how radioactive it is. And there's been a lot of work done on that, but proving those technologies and scaling them up, to an industrial scale is no small challenge. So I think what we're going to see is the Blue Ribbon Commission has the charter to consider everything in terms of the future of nuclear energy and the nuclear fuel cycle. So reprocessing is certainly one of the things that that we may do.
Let's go to Glenn in Chalice. Glenn?
Yes. Hi. I was just wondering what they're going to do for nuclear energy. Is it going to be clean? Is it going to be put to good use? And all that? And I'm going to go to my TV, and right when I hit the mute button, I'll listen to the answer.
Okay, thanks.
Okay. Thanks, Glenn. I'll go back to some comment I made earlier. I think all large-scale forms of energy generation have costs, risks, and environmental impacts. And I think if nuclear energy is compared fairly with the other choices, that it'll compete well. It tends to be costly up front. The capital investment for nuclear power plants, for example, is very big. But the fuel costs are a relatively small part of the operation of the plant as opposed to fossil fuels, and they're relatively stable.
What's the environmental impact on the air quality?
Well, I think nuclear energy nuclear reactors and nuclear energy have no negative impact on air quality, and that's again, that's one of the big attractors today. So I think nuclear energy. Again, clean always sounds to me like green, and it always implies that somehow there's free lunch and we can have a lot of energy, and we can't. Even renewables are wonderful, but renewables are distributed and they're intermittent, and there's a cost associated with that. How are you going to store that energy, or are you going to do without it when it's not available? And some level of human activity, industrial activities, and other things, plus managing the intermittency. The complications of managing the intermittency means that we can't live on that alone. So we're going to need baseload power like nuclear energy, and I think it competes well in terms of cost, risks, and environmental impacts.
Let's go to Robert in Boise. Robert.
Yes, this is Robert in Boise. I'd like to ask a question. The injection wells that they used to use in the process of the contaminated water, how long has it been since that's been used, and what have they used to clean those processes up?
Gosh, I don't know. I mean, there are no injection wells, and certainly nothing that injects contaminated water. And there were injection wells in the past that injected solvents. A lot of that was hydrocarbons. A lot of that was extracted by drilling down and providing vent pass because it vaporizes and evaporates. But injection wells are not an acceptable form of disposal. It brings up an important point. We look at some of the things our predecessors did and we say, what were they thinking? I mean, why did they do that? And I'm convinced that in most cases they were good people who were trying to do the right thing. But we've got to remember that 40, 50 years ago, nobody recycled. The answer to pollution was dilution in everyone's mind, and that was in my opinion, that was short-sighted and not respectful of the environment. But the injection wells, those that have presented any environmental hazard, have all been addressed at the lab and mitigated or continue to be mitigated, and we don't do that anymore.
We have about a minute left.
Mm-hmm.
And what do you think the future of the INL is going to be? Where are we going, and are there going to be jobs to go with them?
Oh yeah, absolutely. I think the future of nuclear energy was written here in Idaho in the early days of nuclear energy, and I think we are poised for that to be the case again. I think it's a very exciting time. I think it's extraordinarily important. I think Idaho is the leader in this area of energy technology that's extremely important. Not only to our country, but mankind and its future. So I hope all Idahoans are proud of that, and I hope they come out and look at what's happening on that 890 square mile site, because it continues to evolve and change to meet the needs of the future. It's an exciting place to be.
Director, I appreciate you being here with us.
My pleasure.
Now, if you're on our phones, hang with us. We'll try and catch you on the flip side when we go to our web extra. We've run out of time. Thank you again, Mr. Grossenbacher. I appreciate you being here. If you'd like to learn more about the INL, you can go to the Dialogue website. There you'll find more information, links, and our web-only conversation. Go to idahoptv.org and click on Dialogue. You'll also find us on Facebook. Search Dialogue on Idaho Public Television and become a fan. You can look for our shows on YouTube and on our website. Thanks for tuning in, and join us here next time for Dialogue. Now.
Presentation of Dialogue on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family's legacy of building the great state of Idaho. To order a copy of this program from Idaho Public Television, call our toll-free number or visit us on the World Wide Web.